Our next lesson is called Categorizing Rational and Irrational Numbers. So it says the set of real numbers is made up of two distinctly different numbers, those that are rational and those that are irrational. So if you remember from the real number system, we took the real number system as all numbers and we split them into two groups, rational and irrational. These types of numbers mix and match in various ways, as when we simplify the square root of a non-perfect square, or when these numbers are added together and multiplied. So what I'd like you to do is complete an investigation in questions number 1 through 3 with a partner. And if you're watching this video, you may be doing this by yourself. And you're going to complete the investigation 1 through 3 by completing the tables to determine any number patterns you notice when you mix and match rational and irrational numbers with the operations of multiplication and addition. Use your calculator to perform all of the arithmetic. So we're not asking you here to use your skills for multiplying radicals or adding radicals. We want you to go directly to your calculator and just type those numbers in order to answer these questions. So the general overview here is you've got investigation 1 that's going to match with multiplication. We want to see what kind of numbers are the product of two rational numbers and what kind of numbers are the product of two irrational numbers. And then underneath, you'll be asked to do a conclusion. It's going to say circle one of the bolded words to make the sentence true. So you're going to investigate what goes on with these numbers under certain operations and be able to make a final conclusion about the special combinations. That same setup is going to happen for number 2, which is matching with addition. So what kind of numbers are the sum of two rational numbers? What kind of numbers are the sum of two irrational numbers? With conclusions. And then number 3, it says, lastly, let's mix. So what kind of numbers are the product and sum of rational and irrational? And then the conclusion. When you get to the conclusion of number 3, you can resume the video and we can talk about the exercises together. So again, at this time, please pause the video, complete investigations 1 through 3, and then we will go over the answers together and complete the exercises. Okay, so now you've had the opportunity to complete the investigations. Let's go over the answers and some of our conclusive thoughts. So in number 1, we were doing all multiplication. We wanted to know what kind of numbers we'd get when we multiply two rational numbers. Remember what rational numbers are? Decimals that end, decimals that repeat, numbers that can be written as a fraction. So you had the examples of 5 times 2, which is 10, negative 3 times 4, which is negative 12, 1/4 times 2/3, which is 1/6. All of those resulted in rational numbers. So that's telling you when you take two rational numbers and you multiply them, you always, as I circled below, get another rational number. Okay, so what I'd like you to do though now is add the word closed next to that. Closed is a term that we use and we refer to when you take two numbers of the same set and you do an operation and you still get the same answer in that set. It's not something that we expect you to use, but I did want to make you aware of that vocabulary. What we need to remember is that a rational times a rational is always a rational number. On the other side, we have two irrational numbers, product still, so multiplication. So you can see the first two, we get these kind of ugly decimals that go on forever and never repeat. Those are both irrational. However, if I take the square root of a non-perfect square and I times it by itself, that's an irrational times an irrational, I get the number 5. That's a rational number. So here, the product of two irrational numbers is just sometimes irrational. So this is an example of something that would not be referred to as closed. We didn't get something from the original set. Going on to number 2, we're going to match with addition this time. So we did the sum of two rational numbers first, and we had 3 plus 8 is 11, negative 4 plus 7 is negative 3, positive 3. And then 3.7 plus 5.82 making 9.52. All of those are rational answers. So once again, we can say now that the sum of two rational numbers is always rational. So rational numbers would be referred to as closed. But what you need to remember is a rational plus a rational is always a rational. On the other side, we have sum of two irrational numbers. So in the first example, we got a decimal that goes on forever, never repeats, so that's irrational. However, if we take two irrational numbers that are opposites, like we did right here, you see we get 0. So 0 is actually a rational number, and then the third one, similar to the first one, is irrational. So this again is only sometimes for addition and irrational numbers. Then we mixed. We did product and we did sum, and we did rational and irrational together. So over here, if you take the product or you multiply a rational and an irrational, you're always going to get an irrational number. And on the right, if you take the sum of rational and irrational, you're always going to get irrational. So that's something interesting to see when you're mixing them. Okay? So now we want to take a look at the exercises. It says, based on your conclusions on the previous page and above, which of the statements is always true, which is sometimes true, and which is never true? If the statement is sometimes or never true, give an example to support your reasoning. So again, if the statement is sometimes or never, you need an example to support why you're picking what you're picking. And the way I would suggest you do that is find the exception. Find the example where it doesn't work to prove why you're picking sometimes or never. So let's look at letter A together. The sum of a rational number and a rational number is rational. So that's talking about the sum of two rationals. Now you can think of that yourself, but you also have your table to refer back to. So the sum of rational and rational was in investigation number 2. Our answer was rational every single time. So this one is going to be always true. B, the sum of a rational number and an irrational. So that's the investigation that we just did in the chart on the right in number 3. And it says the sum of a rational and an irrational is irrational. That's what we got every single time in our table, so that's always true. Now C says the sum of an irrational and an irrational is irrational. So when we look at that one, we're talking about sum of two rational numbers, which was an investigation 2. And we saw there was an exception in the middle part of the table when we took negative 3 square root 5 and we added 3 square root 5. We actually got 0. So that one does not always work out. This one is going to be sometimes. And we could use the example from our chart, but just to give you another example, it's anytime you take an irrational number and its opposite, and you combine like that for sum, you're going to get something like 0 every time when you add opposites. And 0 is definitely not irrational. Okay, so that's sometimes true. I'll put true here. All right, D, the product of a rational number and a rational number is rational. So that's rational times rational, which was actually the very first investigation number 1, the first chart we did on the left. We always got rational. So this one is always true. E, the product of a rational number and an irrational number is irrational. So this is product mixing, which is in investigation 3, the table on the left. And so here we got always. And then for F, the product of an irrational number and an irrational number is irrational. So if we go back up to the top, that would be the top of this page, investigation 3, looking at, that would be going all the way back to investigation number 1, looking at the second table, product of two irrationals. and that was sometimes. So sometimes this was always true. This was sometimes true. And remember, we need an example of that. So let's say product of an irrational number. Let's do an irrational number like square root 3 times itself, square root 3. If I take a square root 3 and times it by itself, we're just going to get 3. So there's an example of irrational times each other, and my answer isn't irrational. It's actually rational. So to finish, I would like you to complete the closure question. How can the decimal representation of these products and sums help you determine if it is rational or irrational? So at this time, pause the video, fill in your answer, and then resume to check. Okay, so at this point, you were able to try the closure question on your own. How can the decimal representation of these products and sums help you determine if a number is rational or irrational? So decimal specifically, asking you to activate prior knowledge when we talked about all the subsets of the real number system. Rational has the word ratio in it, means it can be written as a fraction. Those fractions turn into one of two types of decimals. Terminating, which means they end, or repeating. So when you did this activity, if you got a terminating or repeating decimal, you knew it was rational. And for irrational, you want non-terminating, so no end, and non-repeating, so no pattern. Think of it like that, no pattern. Goes on forever, but there's no repeating pattern. And this concludes your lesson on categorizing rational and irrational numbers.